In this video, we're going to take a much closer look at power factor correction. We've touched on power factor briefly in our previous video, which you can find in the description. By the end of this video, you will know exactly what you need to do to improve it and realize savings. As a short recap, you need to know what power factor is before you look at correcting it. Power factor is basically a measure of how effectively electrical power is being used in your organization. A perfect power factor of 1 means that all of the electricity supplied is being used productively as true power. However, when the power factor drops below 1, say to 0.7 or 0.8, a significant portion of the power supplied is reactive power, which doesn't perform any useful work but is needed to maintain magnetic fields in inductive loads like motors and transformers. In an industrial setup, most equipment, like motors, compressors, and even large-scale HVAC systems, requires both true and reactive power. Real power performs the actual work, while reactive power maintains the magnetic fields within these devices. When reactive power demand is high, it adds to the total apparent power drawn from the utility, but without delivering useful work. This inefficiency leads to a lower power factor. A lower power factor leads to higher energy bills, which of course you don't want. So, what is power factor correction, or PFC? Power factor correction is a set of methods designed to improve your power factor by reducing reactive power demand. One of the most common tools for this is the capacitor. Capacitors supply reactive power to your system, so your electricity company doesn't need to provide as much. This reduces apparent power drawn and, in turn, lowers your costs. In many commercial and industrial settings, you'll find capacitors installed across large motor loads or switchgear. These capacitors store and release energy to support magnetic fields, reducing the burden on the utility supply. For larger facilities, synchronous condensers, essentially large rotating machines, can also improve power factor by generating controllable reactive power. Let's say you have a site with a power factor of 0.75. This power factor results in high apparent power demand and incurs reactive power charges from your electricity company. After installing a capacitor bank to correct the power factor to 0.95, your site reduces apparent power demand by as much as 20%, slashing energy bills and eliminating penalties. For a large-scale operation, that could mean savings in the tens or even hundreds of thousands of pounds per year. Beyond direct savings, power factor correction helps protect your infrastructure. Lower reactive power means less current flowing through cables and transformers, which reduces heat buildup and wear on electrical components. This ultimately prolongs equipment life and minimizes maintenance costs, making it an important part of asset management. Reactive power charges are fees added to the electricity bill by suppliers of those with a poor power factor. They do this to help cover the costs of the distribution network, which can increase when a large amount of power is wasted. A site that pays an annual reactive power charge of £20,000, for example, could potentially eradicate that charge by investing in power factor correction equipment. They'd save costs and add operational resilience. Power factor correction also plays a strategic role in energy management and sustainability. By improving power factor, you draw less total power from the grid, which reduces your energy footprint. Lower energy consumption aligns with corporate sustainability goals, like net zero, helping you reduce greenhouse gas emissions as part of your larger environmental commitment. Improving power factor may seem like a minor adjustment, but its impact can be significant when your company is actively reducing unnecessary energy demand that directly contributes to a smaller carbon footprint. By improving energy efficiency, cutting waste and reducing costs, power factor correction provides long-term financial and environmental benefits. If your organization isn't optimizing power factor yet, it's worth taking a closer look. The savings could be significant. Thank you for watching. Subscribe for more insights on energy efficiency, and reach out if you'd like to explore how power factor correction can work for your organization.